Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 5. We studied our two drugs class, namely anti-malarial drugs and antipyretic and analgesic drugs, and their compounds are we synthesize in past lectures. Now, in this unit, we have one class, remaining one class, and that is sulfur drugs or antibacterial drugs. In this class, we will study sulfathiazole, sulfapyrimidine, sulfur acetamide, and sulfafurazole. In this lecture, we study introduction of sulfur drugs and antibacterial drugs, and also we synthesize two compounds. Number one is sulfathiazole and number two sulfur acetamide, and remaining two we will synthesize in next lecture. So first of all we start with introduction of sulfur drugs or antibacterial drugs. These are synthetic chemotherapeutic agents which contains sulfonamide, sulfonamide, that is the sulfonamide group, SO2NH2, sulfonamide group in their structure. These were the first effective chemotherapeutic agent to be widely used for cure of bacterial infection in human. They have been also found to be active against certain gram-positive and gram-negative cocci, certain gram-negative bacilli and protozoa. They are not only cheap and safe antibacterial, but efforts made to determine their mechanism of action have given a tremendous impetus to investigate our antimetabolities of therapeutic interest. At present, sulfonamide have been largely replaced by antibiotics in the treatment of most bacterial disease, but they are still used either alone or preferably in combination with the one or other antibiotics. If an antibacterial agent can simply stop the growth or multiplication of bacteria, it is said to be bacteriostatic. It is not that. What is the bacteriostatic? The compound which simply stop the growth or multiplication of bacteria is said to be bacteriostatic. And if the drug kill bacteria at tolerable dose, it is called bactericidal. So that both are the definition of bactericidal and bacteriostatic. Sulfur drugs are bacteriostatic while antibiotics are bactericidal. It is noted that sulfur drugs are bacteriostatic while antibiotics are bactericidal. The discovery and use of sulfur drugs is an important step in development of medicinal science. This is the introduction of sulfur drugs or antibacterial drugs. Now we start our synthesis. First of all, we synthesize sulfathiazole. Sulfathiazole is intermediate compound of thiazole. So first of all, we synthesize 2-amino-thiazole, and then after we react these 2-amino-thiazole and get sulfathiazole, or sulfathiazole is also known as its trade name, known as cibazole. So you have prepared these drugs as a sulfathiazole or cibazole. Now we start synthesis. Sulfathiazole is synthesized by interaction with thiourea and 1,2-dichloroethyl ether. In interaction, condensation process is takes place and removal of hydrochloric acid and ethanol, we get 2-aminothiazole. So that interaction between thiourea and 1,2-dichlorodiethyl ether gives 2-aminothiazole. Now we see the next step. First of all, for main our product sulfathiazole, we start with acetanilide. Acetanilide. We treated chlorosulfonation of acetanilide in presence of chlorosulfonic acid ClSO3H. On a chlorosulfonation of acetanilide, we get product para-acetanilide sulfonyl chloride. Para or a 4 if numbering given, so 4-acetanilide sulfonyl chloride. Now this 4 or para acetyl amino benzene sulfonyl chloride is treated with 2-aminothiazole, which is we synthesize above. So reaction between 4-acetyl amino benzene sulfonyl chloride and 2-aminothiazole gives N4-thiazole 2-vial sulfonyl phenyl acetamide. N4-thiazole 2-vial sulfonyl phenyl acetamide. This compound N4-thiazole 2-vial sulfonyl phenyl acetamide on hydrolysis gives our main product sulfathiazole. In this reaction, when hydrolysis occurs, then this acetyl group CH3CONH is converted into NH2. Here acetic acid is removed and it is converted into NH2. So on hydrolysis with N4-thiazole 2-vial sulfonyl phenyl acetamide gives sulfathiazole. Now medicinal application of sulfathiazole. It is a powerful bacteriostatic sulfonamide drugs. Please remember the meaning of bacteriostatic. Bacteriostatic. So, it is a powerful bacteriostatic sulfonamide drugs. It is less toxic than sulfapyrimidine. It is also our one drugs in this class. So it is less toxic than sulfapyrimidine. And last, it is particularly useful against staphylococcal infection and in bubonic plague. This is the medicinal application and synthesis of first sulfide drugs, sulfathiazole. Now we see the next compound. It is sulfacetamide. Sulfacetamide. First of all, we start synthesis from acetanilide. So, for sulfacetamide, we have starting material acetanilide. Now, on reaction with chlorosulfonic acid, here we treated as chlorosulfonation. On chlorosulfonation of acetanilide gives 4-acetyl amino benzene sulfonyl chloride. 4-acetyl amino benzene sulfonyl chloride. It is noted that here sulfonyl chloride group SO2Cl2 is introduced. Now, on amination of this 4-acetyl amino benzene sulfonyl chloride gives N 4-sulfonyl phenyl acetamide. On amination of 4-acetyl amino benzene sulfonyl chloride gives the product N4-sulfamoyl phenyl acetamide. Now this N4-sulfamoyl phenyl acetamide is treated with acetic anhydride. Here acetylation or acylation unit process is applied. Our product is diacetyl derivative of sulfonamide. Here see that here also acetanilide group and here also acetyl group. So it is diacetyl derivative of sulfonamide. We say that sulfonamide group SO2NH2, this sulfonamide, so this compound is diacetyl derivative of sulfonamide. In next step, partial hydrolysis is takes place. So one acetyl group of this diacetyl derivative of sulfanilamide is converted into amino group. Noted that here CH3CONH2 on partial hydrolysis it is converted into NH2. So in final step we get our product acetamide. Now industrial or medicinal application of our product acetamide. It is one of the highly soluble sulfonamide drugs. It is excreted primarily in the urine because of its high solubility and ready elimination. It has found considerable use in urinary tract. It is noted that it is most useful for urinary tract infections because it is possible to maintain high urinary concentration without danger of kidney damage. It is the main benefit of it. It is not damage kidney. So it is highly useful in infection of urinary tract. Sometimes sulfonamide monosodium salt is used. It is very soluble in water. Its solution is suited for repeated topical application in the local management of ophthalmic infections susceptible to sulfonamide therapy. So it is used in eye treatment. In sometimes if we have eye infection, so there is a one component sulfur acetamide is used in the drops of eye. Okay, we stop our lecture here. Take care of you and your family. Thank you.